This is the monthly Temporal Meetup where we have interesting speakers who are mostly featured users from our wonderful partners and sometimes customers. And also we have updates on Temporal and all that other good stuff. Today is, I'm really excited about today's agenda because it's got a good mix of all the things, which is why we love showing off the latest and greatest in Temporal. We're also using this as a seed for what hopefully will become our first conference sometime this year. So that's about as much as I can say about that. But if you're excited about Temporal Conference, definitely make sure that you're on the Meetup sign up list because we're going to be mailing you all to sign up whenever we open for registration. Okay, we have a nice agenda here. So we're going to have our first guest presentation from Mary. And then we're also going to talk a little bit about how Temporal uses Temporal, which is something I'm pretty keen on. We're sort of leaning on the engineers internally within Temporal to show off how we're building Temporal Cloud using Temporal. So this is the first of hopefully many, and Joe kindly volunteered to be the guinea pig there. And also we're showing off a new thing that we're doing with learning paths, building a full end-to-end application. I won't spoil any of it. I'll leave it to the team to do it, but I'm pretty excited about that as well. So, and then obviously we have Q&A at the end. So please feel free to drop your questions in the chat, and of course, stick around if you want to have an extended Q&A session. A couple of updates. We have a lot of Temporal content. So we on the left-hand side, we have Temporal first-party content, which is the stuff that we try to put out. So this is mostly the focus. My focus has been on Temporal in production. So helping people understand how to go from Temporal in development to production with auto setup. And then we had a chat with Samar, our CTO, on how to think about productionizing workers. So I highly encourage people to check that out. But also I'm very excited about third-party content, people creating and writing stuff about Temporal from our friends at Nightfall, writing about custom data converters as well as Yugabyte. So if you're interested in writing blog posts or talks or anything about Temporal and you want us to review for you or check in, or you already wrote it and you just want us to know, just let me know, let anyone on the DevRel team know, and we'll be happy to work with you because it's something that we really want to encourage and feature on our social media, our content, websites and the meetups, so just get you more stuff. Likewise, Temporal jobs as well. So if you have any job listings that will be using Temporal, we're happy to get people and get eyeballs on your job posting. Okay, I hope this presentation is still going on. So if anyone wants is pitching Temporal internally within their company, contact Dominic on the Temporal Slack, and he'll give you the highly reviewed presentation on how Temporal works. So there's that. Another new initiative that we're also doing for the new year is the SDK office hours. We're starting with TypeScript, and this is an unrecorded, bring all your silly little questions you're too embarrassed to ask in a big venue, and we'll do it every Friday, and we'll just help you model out your questions or your business requirements with Temporal. And I think the last couple of times that we did it, it was really fun because people had some struggle trying to model their requirements and wondering if it could be done with Temporal. And then we just live coded on the spot. It was pretty amazing. So anyone interested in using the TypeScript SDK, just let us know. Okay, I think this is it. Mary, are you around?
Yeah.
Awesome. Well, Mary, it was really awesome to dry run with you. So I'm excited about this chat, but I'm gonna hand it over to you.
Okay. Hi everyone. I'm Mary. I'm a software engineer on infrastructure team at Chronosphere, and today I want to tell you about how we use Temporal at Chronosphere. If you haven't heard about Chronosphere before, we are a hosted observability platform. We offer metrics and distributed tracing to our clients, and we're built to handle big scale and complexity of cloud-native metrics. We are powered by M3DB that was developed and battle tested at scale at Uber, and we have an awesome engineering team. We've been using Temporal since late 2020. We run it on our own. We run it with MySQL and without Elasticsearch. And most of our development is in Golang, so we're using Go SDK. And we have a separate Temporal deployed in each cluster that we support. We have three main use cases for using Temporal at the moment. First one is a deployment system. We build our own in-house deployment system for rolling out our software to production. And another use case, we automated a lot of cluster operations, such as rolling restarts or draining node pools and performing a lot of other infra-related tasks using Temporal. And the third use case that we have is release validation. We wrote a bunch of scenario tests that we run on our software before making sure that we can roll it out to production. So for the rest of this presentation, I want to focus a little bit more on the deployment system and on the patterns that we developed while working more with Temporal. Some of them we used across all of our use cases, but more of them are related to our deployment system. So a high-level overview how we do deployment. We run a separate Chronosphere stack for each tenant that we have. And our stack consists of a lot of stateless and stateful services. So each time an engineer needs to roll out changes to production, they usually need to deploy changes to some subset of the services to some subset of these tenants. And at first, when we were much smaller, we just had one CLI command to basically generate all the configs for all the services, blast it out, and then all the monitoring or making decision whether we need to roll back or performing rollbacks or keeping track of the progress of the work of the rollout. Everything was done manually. And fairly early on, we figured out that this is not going to scale and this is really inconvenient to use as we grow. So we started looking into a better solution. We checked out different existing solutions for rolling out software to production. None of the existing systems that we could use seem to fit our use case very well. So we decided to build our own using Temporal, especially given that we started using Temporal previously for release validation. We already had it ready. So we just decided to automate it. The way we structured our workflows, we have a top-level orchestration workflow, which basically controls the speed of the rollout across tenants, how many tenants you can roll out at once, in which order they should be rolled out. And then each of the deployment tenant workflows controls the same, but across services, in which order the services should be rolled out, should they be rolled out in parallel or sequentially. And tenant workflow basically kicks off underlying deploy service workflows and performs additional monitoring and figuring out, is the deployment going as expected, or did something bad happen and we need to notify the user or roll back automatically. All of these workflows interact with additional external dependencies such as Kubernetes, M3DB operator, object storage, Slack, and a lot of others. So one of the first problems that we needed to solve as we were building this out is performing conflict resolution. At first, we decided to do it very simple and very easy. We decided that we just don't want to allow more than one running deploy tenant workflow at a time. And the way we did it, we used workflow IDs for that. Basically, we generated IDs in a way that we could ensure that only one tenant level workflow can be running at a time. It worked fairly well at first, but then we had more services, more engineers, more changes being shipped to production. And soon enough, it became apparent that we need to allow deploying different services to the same tenant in parallel by different people, by different deploys. But we still should block multiple deploys of the same service for the same tenant. And also, as we started automating additional cluster operations, we needed to make sure that we don't make changes to the tenant from some other operations. For example, we don't do restarts together with deploys, so they wouldn't interact in any weird way. So as a result, we realized that we need to introduce a concept of a log for a service. And at the beginning of the tenant level workflow, we need to try acquiring logs for all the services that we want to change. If we succeeded, then we proceed with applying changes. If no, then the workflow will bail out. We implemented it based on the Mute example that was provided by Temporal, and it worked out fairly well. a bunch of things that we needed to add for it. If you terminate the workflow that initiated the lock, then the lock would still stay open. So we just needed to implement additional logic for handling in that case. And then we also added a query for the workflow that represents a mutex with information about who called it. And it helped us improve the debuggability of this lock-in logic immensely, because in case something doesn't work as expected, you can always quickly find which other workflow acquired the lock and dive deeper from there. Another pattern that emerged for us is the need to perform additional safety checks as we do rollouts. And the way that we implemented it is we introduced a lot of different activities. Each of them is a specific check. For example, are any critical alerts firing? Is a rollout done? Is pod available? And then we have additional helper functions that are executed in the context of the workflow that execute those checks in parallel with other workload changes happening. For example, while monitoring errors, a helper accepts a set of checks that need to be executed periodically, and then a workflow code that should be executed unless one of the checks fails. If something fails, then all the other checks should be canceled and the workflow should be terminated. Another helper that was useful for us is wait for all to pass. For example, let's say you applied your changes to your service and then you need to wait until all of them are deployed. So that's the way we use that helper. The problem that we have with it, because we were fairly new users of Temporal at the time, we just implemented this calling of activity in a loop. So if you have a lot of checks or you have a long running workflow and you need to execute them very fast, then suddenly you can hit the limits on the size of the workflow history. Right now, we're not really hitting it, but we still have a plan to kind of rewrite it as a long running activity with heartbeats, which is a better approach for this. But still, even with this implementation, it was really, really helpful, and we've been using it across all of our workflows, including release validation and cluster operations. Another thing that we used quite a lot, specifically for our deployment workflows, quite often we still need to involve a person in the deployment process. There could be multiple reasons for it. For example, something went wrong and you're not sure whether you want to roll back or just perform some other action. Or if an engineer is rolling out a more sensitive change and they want to have a little bit more control over the speed of the rollout, maybe deploy to a canary tenant first, perform some validations, and only then proceed to the next set of tenants. So for that, we built a Slack application and integrated our temporal workflows with it. So here you can see an example of how one of these confirmation messages looks in Slack. But let's dive deeper into how it works. Basically, the user starts a workflow, and at some point, the workflow reaches a point that we need to ask for user's confirmation about something. We have an activity for that. The activity forms a Slack message and encodes an activity token inside of that message. And the activity doesn't exit as usual. It just returns error result pending, which means that activity will not be marked as completed. Afterwards, the message gets to Slack and the user sees the message and makes a choice, clicks one of the buttons with one of the options they want to select. And as a result, the choice that user made and the activity token will be encoded in the payload that Slack then propagates to our application again. Then we decode the activity token and the response and use Temporal Client to complete the activity using this data. This flow was really useful for us, and I think we're gonna keep on using it in the future. Right now, we're moving a lot of other things into UI for our deployment system, but I think interactions in Slack are still gonna stay with us because they turned out to be really useful and convenient. Another interesting problem that we ran into while working on this automating of deploys is the need to pass large or sensitive payloads to workflows and activities. Because deployment manifests that we need to further propagate to Kubernetes or some other system, they, first of all, can contain secrets, so we don't want them to be stored in the history of the workflows. And they can also be quite big in size, which can also hit some unexpected limits. So as a solution, we encrypt the manifest and save them to object storage. And instead of passing the payload into the activity or workflow, we just pass the path to that object. And then our activities just use some common library code to basically fetch the object, decode it, and then proceed with the actions that needed to be performed. And if one thing that could be useful for us if some sort of support for this was available in Temporal and SDK in the future. So as we worked on Temporal, I think we learned a lot of lessons, but to summarize them, the first one is pretty obvious, I guess, for everyone. Versioning is really important as you roll out changes to your workflows. One of the reasons why it's a little bit more important for us, we use queries on the workflows in order to get the status of the workflow even after it completed. So we query closed workflows a lot, and we store those workflows for a month. So we need to make sure that as we roll out changes, we don't break the replay of the history of them. And one of the things that we've been talking to Temporal team about that could eventually help us a little bit with that and make it a bit less painful with versioning, if the result of the query for closed workflows was cached after the workflow completes. And another lesson that we learned that you need to be aware of the history size limits. And basically, as you design your workflows, you need to think about how is it going to evolve over time and whether you can suddenly start hitting those limits. So thank you. That's everything I had for you today. And in case this kind of problems sound interesting to you and you want to find out more about open roles in Chronosphere, you can find them at this link.
I have a little applause track now. So that was awesome. Thank you so much, Mary. That was really great. If you don't mind, I think we have some questions that might be popping up. So
yeah, sure.
Artem, did you want to come on and clarify the question?
In one of your slides, you said you had to deal with this problem, and I know you have to deal with it because we are trying to use the same pattern and probably want to deal with that too. So what we used like just a timeout for now. But I'm curious, like, how did you solve that?
Yeah, I believe we have like a long running activity with the hardware that basically checks if the caller workflow is still open.
I see.
So that's the way we solved it. It's nothing special really. But yeah, it's only for termination, I believe. I think if the workflows are canceled, then I think it's propagated properly. It's with termination that we had issues with.
Yeah, if it's termination or if there's like, again, logic is broken in the workflow, I just forget to cancel it. Yeah, okay. Thank you.
Awesome. And then we also had, I think there's a question from Andrew about retention period. Yes, I think it's 30 days. I'm not sure if it's like hard coded or anything like that, but we always limit our users to 30 days of retention for workflows. So yeah, being able to cache that and query that probably is useful for some use cases. Okay. Gregory Warner asks, self-hosting or temporal cloud? I don't know what Mary is allowed to say there. Mary?
yeah, but we're running our own temporal at the moment, so.
Yes. And also, I think the other thing that I really enjoyed learning about you is that you came from Uber and Chronosphere also an ex-Uber company, and I think so the team is probably very familiar with using both together. Or I don't know.
Yeah, I used Cadence like before while I worked at Uber, but we have some people who worked on it with it more closely. We also have a lot of people who started actually using Temporal who didn't know anything about it. So I feel like we have a good mix of everything at the moment.
Is it easy to onboard them?
Yeah, I think it was fairly easy. It's still a little bit tricky to figure out at first how it works, I think. But one of the things that was really helpful is that we can run it easily in with Docker Compose. So it's really easy to test locally. And I think that helps people just kind of gain confidence and experiment a little bit more.
Yeah, we love the Docker Compose experience. And also, I think something I've been working on recently is running Temporal in the cloud, right? In the browser. So having like a one-click deploy of some samples, so you can try things out easily and reproduce bugs if you have any. Okay, Peter has a question about multi-tenancy. I'm not sure if I don't think you covered that, but so Peter, you want to come and ask your question? You have a multi-tenant installation. Yeah, go ahead.
Yeah, I'm there. Yeah, we are multi-tenant, but the amount of tenant is moderate, right? So per region, we have no more than 10 tenants. And we are using namespaces, and we embrace namespaces, and we like namespaces, right? Makes things easier for us. Okay, we need to start new workers for each of those namespaces, but I mean, it's not costly. Right. Do you see any betterments for multi-tenancy, or namespace is the way to go? Do we do it right?
Yeah. So for now, we have multiple tenants running like in a separate cluster. So, and we use the same namespace for deploys right now. We didn't really hit any problems with that, but I can imagine that splitting them by namespaces could be a good way to go. We decided to basically have a separate temporal deployment for each cluster at the moment.
Right. Okay, thank you.
And then we use namespaces also for because we have different usages, right? So we have a namespace for deployment related workflows, and then we have cluster operations, some namespaces for service validation. So I think we use namespaces more for kind of separating the use cases right now.
Okay, cool. Thanks a lot.
Yeah. Awesome. Okay. Eli says that was also very closely related to the problems you're coming up with. Eli, if you have any other questions to follow up with, now's a good time. And then, I think that was it. Does anyone else? If anyone else has questions, I think Mary will be available in the chat. But otherwise, thank you so much. This is a really awesome presentation, and it's a pleasure to work with you on it.
Thanks.
All right, thanks, Mary. Awesome. So round of applause, everyone, for Mary. I thought that was really nicely done. I can see people applauding in the chat. Thank you, Rob. Okay, so I think Joe is up next. Joe is our infra automation expert, I guess, if we can call him that. Let me see if I can get him on. Let's see.
I'm Joe Andaverde. Let's see, we're going to talk a little bit about how we do infrastructure automation here at Temporal. A little bit of background about me. I've been doing infrastructure automation for a while now. I worked at HashiCorp on HashiCorp Cloud Platform for, just a little over a year. Got from, from pre-beta to GA in that period of time. On Azure and AWS, and so in that time, picked up quite a few tricks, and wanted to share some of that. Brought that along with me to here at Temporal, and it's how we're provisioning infrastructure. I think for what it's worth, we use a combination of Terraform and typical SDK calls to provision infrastructure, because there's some things have Terraform providers, some don't. Many do, actually, and so we have a combination of those things. And one of the motivations, before we dive into this deeply, for using the Terraform providers is just that rich ecosystem that Terraform and HashiCorp has amassed with respect to the providers. And if you're not familiar with what a Terraform provider is, because the word seems quite a bit overloaded, a provider is a library, if you will, or a set of code to perform actions against a service: create, read, update, delete. And the Terraform project will transform some HCL, the configuration language, into calls to that provider. So, and then it handles sort of the relationship between resources and the directed acyclic graph that that decides what order to create things and pipes values around. So if you're not familiar with that, go check out more. Hopefully I can give you an idea of how it might be valuable and how that works with Temporal in this talk. So as I said, I bring a lot of this experience from my time at HashiCorp. And we were provisioning resources on AWS and Azure using Terraform. So I don't know where like exactly things are today, but I do know when I was there, this was one of our primary mechanisms for provisioning infrastructure. Of course, there's a whole lot more that goes on besides just provisioning the resources. There's managing them, lifetimes, things that also Temporal is very good at doing. But today we're going to focus really on just provisioning the infrastructure. So I think, we started with some pretty simple proof of concept here at Temporal. As you know, we're a startup, and you do what you need to do in order to sort of get down the road. We are now all automated. Our infrastructure is automated, and yeah, these are some of the learnings and why we did it. So let's jump into a quick overview of what you're going to see here. So we're going to go through a code demo, and this code demo is available on GitHub. And the general architecture of what we're talking about here is that you've got a workflow that handles something, and this workflow can be quite long, right? You can provision hundreds of resources throughout a single workflow, and then within each activity, you can provision some subset of those resources. Now, that could be one, that could be two. I typically like to keep that pretty low. You want to think about with activities like where your logical breakdown of your resources in your infrastructure. For example, what we're going to do today is we're going to create a network, a VPC, and we're going to assign subnets to that network. And the one logical way to think about that is that you can create the VPC separately and then create the subnets as a separate step. And then you imagine just gluing these things together over a fairly complex infrastructure, and then you get all the benefits of orchestrating these different infrastructure inputs and outputs from Terraform and from activities, and orchestrating them all together to make just an amazing infrastructure experience. It's been my experience, at least. So the goal of each activity is for it to be retriable, and we do some work inside of that activity to think about how we can make it idempotent. So for example, if an activity for whatever reason gets canceled or gets killed in the middle of the process or gets terminated for any reason, you want to be able to pick up where you left off, right? So activities should be written in a way that allows you to deal with transient errors. Whether, one big source of problem that you could probably imagine may not typically think of as a problem, but let's say you're rolling out all of your workers, you're re-rolling them, or you're terminating a pod, but it's executing an activity at that moment. So you want to think about your activities as idempotent, and you want to make them so that every run of the activity results in the same thing. That's another way of saying that. So what we have here is some demo code that wraps, that handles some of that, the details of what it means to be inside of a temporal activity. So as you know, activities have some amount of heart beating that needs to happen. So that, if they've gone rogue, they've stalled or whatnot, or, simply just aren't responding, then if they're not sending out a heartbeat, the temporal is going to schedule that activity to get run again. And so what we want to do is that, and because of the way, if you go down a couple of layers here to Terraform execution, we're going to shell out to Terraform. And if you actually look at the Terraform CDK, from my experience at least, or from what I've seen, it does similar things, though it kind of skips the HCL language. So the Terraform CDK also shells out to Terraform, and it seems to be, kind of the way things are now. Though in the future, who knows where this will go? Like if you're still going to be shelling out to a binary, or if you'll be able to do this stuff in process. So we've got this activity wrapper that understands heartbeating and cancellation of an activity. And then we've got the Terraform workspace, which is responsible for getting our Terraform files into the right spot, providing the right input variables, mapping, from activity inputs to our actual Terraform execution. And then of course, authentication with our cloud provider or whatever particular cloud, provider, Terraform provider we're using. And then the next layer down is a Terraform execution. And this just handles the signals. Like, so if your worker gets canceled, we want to be able to give Terraform the opportunity to save its state and exit nicely. Because if it doesn't, that could be pretty unfortunate, because state may not be persisted. And so your infrastructure will be inconsistent with what Terraform thinks. Now we try to mitigate some of that issue, which going back to making this idempotent and making the goal retriable by importing resources prior to trying to create them. And I think if you keep this small, this could be quite manageable. One of the big use cases that I could think of that one of the first things that, of course, we run our infrastructure on Kubernetes, is that we had used this massive Terraform EKS module, and it provisions IAM, it provisions node groups, creates launch templates, and it does a whole mass of things. And I don't think I can name a single person that I've ever met that have used that and had a good experience. Particularly because the module is extremely complex, and if one aspect of that goes wrong for whatever reason, or you're trying to do upgrades, it just doesn't quite work. So my recommendation, at least, is to try to break that down into smaller chunks. And so what I ended up doing was doing precisely what we're about to talk about today, or what I'm about to show you, is break it down into small chunks. Let's create the EKS cluster. Let's go ahead and create the IAM users or IAM roles separately, and think of these as different atomic steps, perhaps, even though they're not really atomic. But if you think of it like that. And then the next step might be create the launch template, then create the node groups, and then break each of those into an activity. And then suddenly you've got a pretty resilient way to provision infrastructure, and you got to take advantage of Terraform and its provider ecosystem. Now you might be wondering, okay, so if I'm breaking up this into a bunch of small chunks, why am I not just invoking each API call for those small chunks as a separate activity? That's a good question. And that's totally a possibility. However, there are in my experience, there's been situations where the Terraform provider will handle certain edge cases that are specific to one endpoint of the cloud provider. For example, I believe, and I could be wrong about this, that the creation of an initial VPC, I believe it deletes some default security group or adds one, or there's some stuff that goes on there, and that's very nice. And you can think all the mileage that has gone into this rich provider ecosystem you get to take advantage of. So with that said, let's jump into a demo. Time check, Sean, how much time do I have for this demo?
Sorry, I was playing some sounds. I think you're good for about 10 minutes.
10 minutes. Okay. Yeah. Well, let's give this a try. So what we're actually going to do is we're going to provision some resources. So I'm not blowing smoke here. We're going to go ahead and jump into some code. So what we have to start off with, and I'm going to blaze through this first part because of the time constraint, but we've got, connecting to temporal, we've got, connecting to the worker, the appropriate task queue. You can look up our examples about how to do this and even take this repository and run with it because it has a Docker Compose, and I've already Docker Compose created everything. And so what we have is a, a local host port 8080, default namespace, nothing going on, right? So we've got a worker here that we can launch. We're about to launch, and if everything goes well and I didn't mess this up, then you know how it goes. Demos. We're going to start creating a VPC. So and what I'm going to do is I'm going to kick off this workflow, and we're going to let it go, and we're going to talk through it. Just so you also are aware, I've got my AWS account here with no VPCs in it, no subnets. Oops, sorry for the zoom there. And we've got an S3 bucket that we're storing state in. You can choose whatever state you like, your backend. You don't even have to do any of this on AWS. So let's go ahead and create something. So going back to the VPCs, we're going to keep that up. And I'm going to kick off a workflow here, and I should have an input available. And we're going to do this. You can do this, build your flavor of UI or whatever. Or if you just want to, kick it off with the tcuttle command. And let's see. So we've got the task queue that we saw on that first, on the main function, the actual workflow we want to kick off, create demo network workflow. And the workflow ID, demo network, whatever you like. The idea here is just that, one workflow with that ID will be running. And then, unless I messed up, hopefully I didn't mess up the new lines here and this actually runs, but we've got, demo VPC to be created in US West 2 with this CIDR block. And then we're going to create subnets across 2 availability zones. And let's go ahead and kick that off. Cool. So started a workflow with this ID, as you saw, and the run ID is CDB. Let's go to temporal, and I don't know if, am I running the worker? Yes, maybe. Well, we're going to find out. So am I running the, no, I'm not running the worker, which is good. So if we click here, we're going to see, oh, maybe I was. Oh, yeah, I'm sorry. Yeah, I got a little confused there. So yeah, the worker's running, it picked up that workflow, created the VPC. You can see the output from that workflow is a VPC ID, 00BBB7B. And if I go over to AWS, my hope is that if we refresh this, we're going to see a VPC, and we do. It's named demo VPC as we wanted. And then if I refresh this again, we should see the create subnets activity completed. Go back to the actual front page, and we've got a completed workflow. So in this workflow, we created the VPC and we created the subnets as 2 separate activities. And we're going to go back here to the subnets. We'll see that we've got subnet A, subnet B, with their different CIDRs that are cross availability zones. And so that is the state. Here's the state. We'll see that we've got 2 Terraform state files, 2 different activities. And we can jump into those and look at the details, but it might be better to go look at some code now. So let's go into, I'm going to trace the path here. So we started the worker, we've registered some workflows, and I'll jump into that. We registered workflows to create our demo network, the activity to create the VPC, and an activity to create subnets. Whoops, didn't mean to click that. Okay, so let's jump into the actual workflow. So this workflow, and ignore these really short timeouts. I was doing this for demo or for testing. You can pick whatever timeouts feel right, but it's important to pay attention to the heartbeat timeout and your retry policy in general. Moving on, we're going to create the VPC as an activity. The input for that will be, the name, the region, CIDR block, subnets. And then we're going to create the subnets, and then we're done with the workflow. Now, this is all great. You can't really tell that any of this is, Terraform yet. So let's jump into creating the VPC. So the actual activity is where you start seeing some idea of Terraform. And I think if you think of activities like your implementation, this could be a Terraform thing, this could be an SDK call, this could be anything. So this is where the nuts and bolts happen. This is where side effects occur. So what we're going to do in order to try to make this idempotent is we're going to look up that VPC by its name. So under this function is just a call to using the AWS SDK to list, to describe the VPCs with that name. And if it finds it, returns it. And that gives us the opportunity to import that VPC into our state. Why would we do that? Well, if for whatever reason our state does not get uploaded to S3, network error or something, this allows us to get a retryable activity. So for anything that you can, that if, for example, the create had attempted again, you want to definitely import that. And sometimes this is actually nicer than going out and looking at the AWS, like going to do a fetch against AWS. Sometimes the names are derivable, meaning like they're just a known value. Like let's say it's the input you gave, cluster name / EKS. But in some cases, AWS generates a name for you, like in this case, a VPC ID that you have no idea and can never know unless you go look it up. So we're going to import that VPC. Then we're going to create this TF activity. The TF activity is the thing in this particular in our demo that understands Terraform, or sorry, understands heartbeating and activities, and it's responsible for like sort of wrapping this Terraform workspace. And so if we go back to our picture here, we've got this Terraform activity wrapper or workspace wrapper. Then we've got the workspace, which extracts Terraform from the embedded file system and prepares the variables and everything. So this section here, where we actually go to apply the Terraform, will do the extracting the Terraform files and getting AWS credentials and providing the variables to that file, to that run. So you're like, okay, where's my Terraform? We've been talking about Terraform, but I haven't seen a darn lick of Terraform. So if we go to actually our Terraform files, the way I've broken this down is that we've got our Terraform files here, and the VPC creation is here. It's very simple Terraform. That's one of the things I really love about this. You can imagine this looks a little bit more gnarly if you're creating types and structs and everything in whatever language. But with Terraform, it's very nice. You can just use this declarative language, get some good, nice autocomplete, and it's good. So, and then the variables that you want to input and the outputs you want to get. So given your inputs, given your outputs, and everything in between is Terraform and Terraform providers. So this uses
just to wrap things up here as well. One of the things that you also mentioned was we do testing as well, right, on inputs and outputs.
Yes, we do. It's important. So part of like making this, it's not just a black. It's kind of a black box when it goes to running Terraform right now. But what we try to do as best we can is test that we input the correct inputs and ask for the correct outputs. So, and then, then kind of it's off to the races what happens inside of the actual Terraform, which is kind of a blind spot, but with good testing and good integration testing, that kind of works itself out. So the embedded file system here uses the Go embedded file system to include the Terraform files in the binary. This is one of the big things that people are concerned about, is like, well, where do my files live? Like, I got to build them into my Docker image. What do I do? Well, in this case, we're using Go's embed FS to actually embed those Terraform files into the binary, which gives us the benefit of the code matching the Terraform, and everything else that comes with the Go single binary thing that we've all probably loved to some degree. So the Terraform activity, as I said, is just a simple wrapper that handles heartbeating. And so if we go into the heartbeat, we'll see here that we just begin heartbeating in a Go routine, and we listen for the activity to get canceled or the context to get canceled, and in which case it would cancel the the heart beating. So welcome to go check this out, dig into it in a little more detail. But just so you know, that's what keeps it so that we could run this possibly long running Terraform. All right, the actual execution, probably not worth going too deep into, but what's important here is that we give the thing that was tricky, I suppose, in this whole experience was giving Terraform the ability to shut down gracefully, right? Because I said, we've got this thing that we want to be able to run idempotent. We want to give it the best chance of being idempotent. And so we want to handle signals. So if we get a SIGINT to the process, we want to forward that on to Terraform, and Terraform then has provider sub processes that it needs to communicate with. So there's like this process tree that needs to be handled in order to terminate gracefully. So there's some cross-platforms-ish stuff going on here with with how we handle when the parent dies, on the parent process being Terraform, when that process goes away, what happens to its children, and whether they get disowned or there's all that kind of stuff that has to be handled here. But the thing that's important here is that we're handling signals and we're giving a good opportunity to shut down. So in our output, what we didn't get to see was what happened. So when we ran that activity, I'm going to scroll to the top here. We did the create VPC activity, and for now I'm piping all the output from Terraform just out to standard out for this process. And you can see here that it's like, okay, I'm going to create a VPC. Here's what I'm going to do. It says I plan to add one. It creates the VPC. Here are my outputs, and then it goes to the next one, which is our subnets. Our subnets activity then says, okay, I'm going to create subnet in US West 2A and US West 2B and create those, and then we're done. So this wouldn't be a complete demo if
got to give you a final 10 track. Sorry. Oh
yeah, so I'm just finishing
there
up.
We go.
Yeah, so this would be a complete demo if I didn't kill everything that we just did, right? So let's go ahead and destroy. And where is my? So now we got the create, we got the destroy, and before we know it, we should no longer have. Let's see. Resources in our VPC is gone. So we got creation and we got the cleanup. And cleanup's almost free. So I'm happy to answer questions or anything offline. Check out the GitHub repo. I don't know if I shared that yet, but that is.
I shared it for you on the chat. Yeah.
Right there.
Yeah.
All right. Thanks.
Joe, that was amazing. Thank you so much, and sorry for the type checks. But yeah, that was awesome. Round of applause for Joe, everyone. And that was a really great overview of how we do infra automation. I think it's something that we're pretty proud of. And it's something that we took a while to evolve towards. Yeah, thanks, Joe. All right, so next up, we're going to have the learning paths team. We're going to run long for this one. So if you can stay with us, otherwise, we'll separate this out and post it as a recording. Ryland, do you want to kick it off?
Yeah, thanks, Sean. And I'm sure Joe will be happy to answer questions in Zoom chat. So if you have any questions about what Joe was talking about, please do that. So yeah, this is a kind of exciting thing to present about. This is a new one for us at Temporal. So we're going to be presenting about what we call the learning path. This is a project that we've been working on for a few months now. It's not quite ready, like in terms of general availability, but we wanted to give people a sneak peek. And so considering how much of a team effort this was, it's actually going to be a team presentation. So just from like an agenda point of view, I'm going to start with like a 10,000-foot view of what the learning path is and why we actually made it. And then Tio is going to be demoing the learning path itself and demonstrating what the user experience is around it. And then Coley, who leads our documentation team at Temporal, will talk a bit about the narrative and then the tutorial and guide we built for the learning path. And then Rob and Smitty are going to talk about the application itself and the architecture. So from like the 10,000-foot view, the learning path is our first step towards solving a problem that we've been aware of for like a long time here at Temporal. And the core problem is that, Temporal is a very complex technology, as I think everyone knows, and it really requires you to think about things differently and think about the way you build things differently. And so over the last year, we've made a lot of tremendous improvements to our documentation and the examples and other resources that all just, help make the experience of learning and using Temporal better. And while it's like really important, that stuff is, very, very critical and it helps a ton of people. There's clearly a separate experience, which is not solved for with like this traditional documentation. And specifically, we're talking about like a guided experience that takes you from first landing on like our homepage with a problem to solve to having something that's production ready with Temporal. And so the learning path is intended to provide that missing experience. And so we've taken a canonical Temporal use case based on our real customer case study. In this one, it's background checks. And we've turned it into like a robust and comprehensive tutorial along with like a reference application. And what separates this from any other tutorial is the practicality and the context. So instead of just walking you through the motions of, building an application, the learning path provides you the business context and the considerations that motivate the design and the choices which we make at the technical level. And so our hope is that this will allow users to map their similar, but like not identical business problems to our learning path. And that way they can gain value out of the reference application and tutorial, even if their specific problem is a little different, which it almost always will be. So this like all sounds great, but what does it practically mean? And so for that, I'm going to hand it over to Tio to demo the thing we've been building.
So as Rylan said, background checks can be very complex. A background check can have multiple checks and a number of different rules depending on, for example, what region, what type of job you're applying for, things like that. In addition to that, background checks have a lot of different actors or decision makers that can involve both systems or automated system, but also human actors that have to make decisions during the background check process. So as far as the demo goes, we try to document this as also implement, of course, that use case as close as possible. So we have, starting a background check, we do have some sort of role as a company HR person that is performing, starting a background check for a certain client. And for that, we use, application has a little CLI that you can run. And I've already ran that on my local system and started a background check process. Now, workflows are perfectly suited for implementing a use case like this. And as you see, of course, we have a workflow running. This is our background check workflow. And once we have started it, it is stopped or waiting for a completion or an acceptance of the actual client that is going to, that we're performing the check on. That type of human interaction we're modeling in our demo with a mail client. So it's typical that the client would receive an email, and this type of client would say the human step itself can have multiple steps through and defined, of course, via the workflow. So in our case, our acceptance of a background check by client has 3 stages. The first one is just an acceptance. Hey, this particular employer has started a background check on your behalf. And now as a client, I have to type in my personal information. I type in my name, a social security number, and let's say I work at Temporal. And now I have a human decision that to either accept or decline, which is of course going to signal our workflow to do something according to this particular decision. So let's say in our case, I accept, I get a congratulations message. And if we look back at our workflow, we have started a number of checks for this particular client. Things like federal search, motor vehicle search, state criminal search. Those are the types of searches that we can define in our workflow as far as our control flow logic goes. And those can be automated checks. For example, we are interfacing with some sort of services in different counties, in different places. They're automated, so we get an automatic response. Some of the checks are not automated, so we need human interaction. Again, in this case, for employment verification, we actually have to dispatch a human, in this case, what we call a researcher, to actually go to some sort of place where and verify that I am actually employed at Temporal. So for that, again, our workflow is currently there, and in our email system, we can see another email, which is the employment verification request. That particular human interaction, defined, of course, via workflows as well, has 3 steps. One is, okay, just to say hello, researcher, a candidate has requested that you perform a manual check on employment verification. And now let's say that I am the researcher, I'm gonna go figure things out based on the user information. And let's say that, yes, I confirm that I'm actually employed where I say I am. And this third one is kind of like a thank you, and that process is complete. Now, in our case, for this particular checks, this was the last step of the check. So if we refresh our web UI, we see that our workflow has completed. Now, the completion, of course, has to trigger some sort of results. And in our case, we also simulate next actor in our process, which is the hiring manager in this particular case. And this hiring manager receives an email in our demo, says, hello, hiring manager, your background check for this particular candidate has been completed. And let's say now I take the role of the hiring manager, I can view my report, and it includes the number of checks and some sort of results. And you can see that this particular, I have a speeding ticket, for example, in this case. The last thing I wanted to demo is our application. Also, one of the cool things that you guys can actually utilize is comes also with metrics. So Temporal provides also both server and SDK metrics. So out of the box with our demo, when you started, you get that for free. So you get Grafana is started for you automatically. You don't even have to log in this case. And you get 2 dashboards for free. One is the SDK dashboard that shows SDK metrics. And the other one is a Temporal, called Temporal, which is a dashboard that shows more of your server-side metrics that were measured during the execution of the demo. All right, so that's it. Thank you guys very much. And with that, I'll take it off. Cully's next, right? So yeah, go ahead.
Yeah, Coley's going to talk to us about how we actually guide users through this entire process and the application that we built.
Awesome, thank you.
Thanks, Tiho. So yeah, one of the main goals for us is to extensively document this project. We're documenting the user journey and how to use it, of course, as Tiho pointed out, but we are also diving into very deeply the design decisions. So if you look at any of our core concepts or practical implementation guides and the documentation, it often lacks recommendations, when to and when not to do something, for example. Instead, you often see a list of things to consider to try and help inform a decision. And that's because often it depends on what the use case is and what you're trying to do, such that documenting the recommendations at the core level becomes challenging, to say the least. So that was actually one of the factors that pushed us to build this application in the first place, as Rylan mentioned. So these learning links will send you over to the docs, right? And there's a lot to explore here in terms of application requirements, building the application, deploying the application. Some of it's missing at the moment, work in progress. But what I want to highlight is that all of this is a large chunk of documentation that focuses specifically on the design decisions that came about as a result of the application requirements within the context of a specific use case. So, for example, what businesses, some of these things you can look at, but it's not limited to what business processes we have mapped to temporal primitives. Why have we decided to implement specific patterns over other patterns? And in what scope have we made these decisions, and how might those decisions change if things were different? So these are the sort of philosophical points that are really difficult to address at the core documentation level, but they're much easier to reason about in the context of this specific use case. As with the application, the documentation here has the ability to grow and answer all sorts of questions. So community feedback is going to be highly encouraged and welcome. If you have a question about the application that is not answered in the docs, then let us know and we'll try to address that. The best way you can do that is by creating an issue back either on the background checks repository or the documentation repository. So thank you very much, and off to Robin. That's me.
Yeah, so Robin Smitty are going to walk us through the actual architecture of this application and sort of the process we went through to arrive at it.
Great. Yeah, thanks, Rob, for setting up the share. Yeah, so quickly, just to help you get started, we just wanted to give a quick tour of the project repo. The repo contains folders aligned to all of the background check application services. So it's actually going to spin up a number of essentially microservices that simulate all the elements that have been shown. The activities folder, all the functions and Go routines to call external services. There's CLI and UI. The CLI commands that bootstrap the backend and allow you to provide the human-driven responses that you saw in the web UI. The deployment folder contains configuration for Prometheus to scrape metrics from the SDK and the server, the Grafana dashboards that Tiho shared, and then the third-party API that simulates all of the kind of these external service checks that are done. Then the heart of this, and Rob will cover, is the workflows folder, where you'll find all that core business logic, as Cully mentioned. And then finally, the Docker files. If you kick the tires on Temporal using our Docker Compose, we've extended the Docker Compose approach to spin up all the additional services. And then lastly, the start and run CLI helper scripts. Basically we'll build the entire environment and allow you to kind of check in on each of the containers. So Rob, if you want to jump in.
Hey, yeah, so I was just going to walk through the main background check workflow quickly. Just give you a bit of a feel for what the code feels like. So basically the background check workflow is going to take an email address and a tier, which is standard or full, which is what Tiho showed passing in on the command line when we started the check initially. We're going to create some state here, which we're going to record progress with as we go through the workflow. We're going to wait for acceptance from the candidate, so they can either accept or decline. If they decline, then we're going to send an email to let the hiring manager know that the candidate declined, and then we're going to end the workflow there cleanly. Assuming that they carry on and they accept it, we're going to run an SSN trace on the SSN that the candidate gave us, the social security number. And again, if the SSN is not valid, we couldn't get a valid result for it, then we're going to send an email to let the hiring manager know, and then we're going to exit the workflow because there's nothing more we can do. Otherwise, assuming again everything's good, the SSN looks good, we're going to get a list of known addresses back from the SSN trace. We're going to always run a federal criminal search. That's included in every tier that we offer in the background check application. So we're going to start this search, and then if they're on the full tier, so if the hiring manager wants all of the searches run, we're going to run all of these searches as well. And these are all going to be run in parallel because they don't depend on anything else. So they can run alongside each other quite happily to improve the speed of the background check as a whole. And we're only going to run the employment verification if they actually gave us some employment details. So then once all those are started, we're going to wait for all the searches to finish so that we've got our data for the report. And then we're going to send an email to the hiring manager with the details of the searches that we've run and what the results were. And that's the main workflow. And that's the end of our brief walk through the whole thing.
Thank you, Rob. Yeah, so as we said at the beginning, this is something that we've been working on for a while. We're getting very close to having it into a place that, we consider like, let's say GA, but we're still in the stages of, kind of iterating on it and getting people's feedback. So if anyone is interested in just looking over what we've made and, telling us if it hits the mark or if there's things that they would change or, want to see that we haven't done, we would really appreciate that. So thanks everyone for watching and listening.
I think that is a wrap. Thank you, team. That was awesome. And a little bit went a bit long, but I think all in all, very worth it for the amount of work that has gone into the effort. If anyone has questions, feel free to ask us in the Slack. I think I'm just going to put up the Temporal Slack just because we're all running long. But otherwise, thank you so much. This has been a wonderful meetup. I appreciate Mary and Joe and the Learning Paths team for joining us. If you want to join and speak at any of our future events, just email me. Otherwise, have a wonderful rest of your week. Thanks, everyone. We'll stick around for final questions, but otherwise, this is it for the meetup. Thank you.